Всем добрый день. Меня зовут Владимир Ярославский, и
I'm Vladimir Yaroslavsky.
код
We will talk about productive code.
есть. Буквально чуть-чуть о себе. Начал я программировать еще в прошлом
I started to
Мой любимый
program
язык это Java.
last century. My favorite language is Java,
Первая версия была 1.01.
and the first version was
И
1.01.
добавил бы то, что моя система
And
используется в NetBeans, есть такая для разработки, и моя
my printing system is used in NetBeans,
также в Android. Ну и, кстати,
and my sorting is available in JDK and Android.
если кому-то будет потом интересно.
That's my email if you would like to contact me.
В конце доклада я отвечу на ваши вопросы, и
At the end of the presentation, I'm going to answer your questions,
и от меня тоже.
and best questions, they will get prizes.
Сейчас я работаю в Сбере, в команде, которая разрабатывает.
I work now in Sberbank. We are doing Giga IDE.
Производительный код. Ну, давайте.
What is good productive code? So good code is readable, clear. That's for the human, and it should work correctly.
Того, что он работает правильно, очень важно, чтобы он.
In addition to being
хочет ждать
right, it should be.
3 часа.
It should work as fast as possible. No one wants to wait for several days or hours at the previous presentation. We are going to talk about Java, but it is applicable to all other languages. What we're going to focus attention when we will talk about productive or fast code. It's the size of memory, algorithm, complexity, the number of flows, and time of execution. That's what the person really feels. We're going to talk about strings, math, algorithm, algorithms and parallelism. What we're not going to talk is how to tune databases, operating system, interaction system, properties, and even without this optimization, you can improve your code. If we would like to understand how our code works, we can take one of the profilers and find a hot method which is frequently executed and which is instrumental in execution. If you have an application or browser console, you could look at the time of your query execution and to see what works fast and what works long. How to measure time? In Java there is system.nanotime. There is very convenient tool, GMH, Java Micro Benchmark Harness, written by Shipilov. As to other languages, C, C++, there are applicable profilers and utilites. So what are the special things that we are launching this program in Java language? So if you'd like to measure number sorting, if we have an array, to look at the nanotime, and we can sort it and then we can print it, and so many nanoseconds our sorting was done. Would that be correct? We can make our scenario more complex, and we can make these steps several times. We prepare an array, sort it, prepare array, sort it, and if we look at the result, we can see that first the number is bigger, then it's lower, and then it's balanced or stabilized.
Java у нас
Why it happens?
bytecode, bytecode потом исполняется,
Java compiles bytecode, bytecode is executed, and there should be time for stabilization so that JIT compiler would optimize bits of code, and so each iteration gives a different result. In order not to think about all of this, there is tooling available. GMH has thought about this already, that we need to run it several times and use the average value. So we can do that through the library, and we need to do the test. The test is written very simple. There is annotation, how many times we want to warm up our code, so many times to launch so that JIT compiler would optimize it, how many times, how many iterations, and then if we have a method, we note it as at benchmark, and if we need initialization, there is a notation setup.
Минимум кода, да, для того, чтобы
So minimum code to write a right
скажем так,
test.
на логике теста.
So we are focused on the test logic. And if we launch this and give the statistics, at first we do 4 warm-up iterations, and then 4 iterations which would be launched to measure our code. And here you can see that for warm-up, these iterations take longer time. When we launch and we're saying that our code works so many milli or nanoseconds, we need to specify the context, at least the version, GDK version which you used, because from version to version, Java is improving, like sorting started to work faster, and strings are concatenated better. And in order to do some statistics, you should at least specify the number of your version. Let's talk about strings. In Java, in order to sum up 2 strings, you can use plus or plus equals. For convenience, very small code, very convenient. You can take any book, like concatenation of strings. You shouldn't use, but you should use string build. Everybody knows this. However, it's always interesting how slower or how faster it is. A simple code, we are adding a literal 10,000 times for this char, for this symbol. The difference is more than 100 times string builder works faster, because plus string, a new object is created. In string builder, only literas are added, and the string is accumulated. Array list and linked list, they always ask about these 2 collections on interviews. There is array, and as to linked list, it's the 2 linked list. We can add something to the collection and to read something. Use array list. Linked list is bad, but how bad it is and in what cases? Let's add elements to the end. And if we add elements to the end in array list, it's when it's full, we just reorder the array. In linked list, we make a node and tie it to the end. So the time is more or less the same. Linked list is a bit smaller, longer, because we create a node and it's the creation of a object takes time. So they're comparable. Now we add elements to the beginning. In linked list, we make a node and tie it to the beginning. If we want to add it to array list, we need to free first place, so the entire array move it to the right. And that is an extra action. Everything happens natively. However, linked list works 40 times faster when adding an element to the beginning. So in that case, linked list is cool. But let's compare it again. If we add elements to the middle, standard cases, beginning, end, and the middle. If we add it to array list, we need to move half of the array. If we need to add it to the linked list, we need to find that place, the index where we need to put the element. We need to run from the beginning or to run from the end. That is an additional action. And what is faster? So we can see that although array list we need to move an array, but to search for linked list, run this list is 20 times longer. So that's the table, and linked list is losing when adding to the middle, but if we add only to the beginning or the end, then it's quite good and could be used. There is also array deck, which has two methods, add first, add last, and they are working a bit faster. So linked list is popular mostly during the interviews. So we've added elements to the list, but we add elements sometimes, and sometimes we read them. So if we are to measure how much time it takes to read elements, the first, last, and the one in the middle, the reading for array list is a bit more or less the same, because indexing is not important. It's A in it degree. And in linked list, we need to read from the beginning or from the end. And in that case, reading from the middle is many times slower.
Таким образом, если у вас используются какие-то коллекции, да,
so if you have any collections and any other realization, compare them to make your code work as fast as possible. Next is material math, geometry. In one of the projects, we have a sensory screen, and the user makes some is pressing, and that these two pressings are quite far and not close. When the points are not vertical, second case is because the points are too close, and the third example is what we need. So we need to determine those cases. So we solve two tasks, whether the points are far from each other and whether they are on a vertical line, almost vertical. First, we recall geometry, that there is a distance between 2 points. The sum of squares, and we compare it with a constant. Is it more or less? So let's look. We don't need to know the exact value, the distance between these points, but whether they are located far.
Невещественное число,
So
либо да, либо нет.
we have a Boolean answer, yes or no.
Так, целочисленного
And so
ответа
the radius of
нам приходится вычислять квадратный корень, это вещественная арифметика.
numerative answer, we get a
ответ целочисленный.
substantial number, but the answer is wholesome number.
В нашем случае
So let's
образование и
separate this square and compare it with a different constant.
никакой вещественной арифметики.
So there is no
Хорошо, вторая задача.
material
На почти вертикальной прямой.
math.
Ну, то есть у нас есть некий
Are these two points on an almost vertical
7 градусов.
line? That's the second task.
То есть
The
чтобы сравнить углы, мы
error margin could be 7 times 7 degrees. So sinus is the catet and the hypotenusa.
Квадратное, в общем, расстояние между точками. Ну и
So we're looking for the distance between these 2 points and comparing it with the sinus of 7 degrees. Sinus 7 degrees we can have calculated, and then it becomes quite difficult. What to do? Can we make it more simple? So we recall geometry.
Помимо синуса есть еще и тангенс.
In addition to sinus, there is also tangents. And what is tangents? It's catet relation. It's like modules of
разности координат наших точек.
Distance between our points.
Может быть записано все то же.
So we can write this.
С точки зрения математики все это то же самое, это все.
As to the math, it's the same.
Вычисления уже это гораздо проще.
But as to calculation, it's much
да, то есть
more simple.
Число будем делить на другое. Опять вещественное.
So we are going to have
вещественное число.
Material.
И опять, да, нам ответ нужен не угол, да, конкретный.
So we need not only the degree
просто сказать почти на вертикальной.
In real division, but we need to identify whether this line is almost vertical or not.
В математике что можно делать? Можно.
So what can we do in math? We can do equivalent conversion. We divide it by tangents 7 degrees, so we don't have division, x by y, but we have 1 divided by tangents of 7, which is almost equal to 8. So in our case, we can relieve this this formula. So what happens in order to understand whether these 2 points are close to each other and are they on a vertical line, we need to calculate these 2 conditions.
Это, в общем-то, хорошо, то есть у нас уже целые числа.
And it's good we have wholesome numbers.
Но мы же настоящие программисты.
No real math.
Еще. Вот настолько.
No real calculus. But we need to optimize it for the integers, so that we can allow.
Нас интересуют точки, да, вот, допустим, точка А, точка Б.
This
Значит, точки, находящиеся
margin of error.
В конкретном расстоянии, это окружность.
So A point and B point, and there is this circle. The B point is on top, and we're interested in this red hemisphere, and they're almost vertical to B on this arc. So we can replace our circle with a square. We can replace the arc with a straight line, which is more simple than arc. So that B point is out of square, quite far from A. We need to write the second condition. The difference of x on module is bigger than this minimum. These would be points outside of the square.
Да, там никаких квадратов возводить не надо.
Then it's more simple. You don't have to
Ну, давайте еще
do
раз
something with
упростим.
those squares.
Мы же
Can we
настоящие
simplify it again?
программисты.
Because we are real
До
programmers.
конца. Вот давайте
We
посмотрим.
need to simplify it to the end.
Первое сравнение это
So the first comparison is the
вот то, что
difference of
соответствует точкам, которые
x with the minimum.
синими линиями.
This is
Когда у нас точки B
painted by blue lines.
они будут
And when the B line is almost on a vertical line, it would be on this green area, and it would not cross the blue area within our sensory screen. So the first condition we can remove.
Мы получаем вот такую
And then we are getting this
формулу,
very simple formula, very simple condition compared to what may have been at the beginning when we were doing this straight. So as to geometry, this is the first condition and it's correct. But as to optimization, we always need to think about the task conditions. And if we make a measurement, the formula should be faster. So the difference is 2.5 times. Now let's talk about algorithm tricks that you can use. If you have an array and you need to determine its length, if you need to take 1/7 and you need to divide it by 7 or take some kind of a ratio, so you need some kind of a real number. And we turned it into the real calculus.
То есть делая арифметическую, вещественную арифметику, а вот
and making this real calculus, we are getting the integers because the indexes in an array are integers. So how can we optimize it? The most simple method, let's turn this real number into 1 divided by degree of 2. So we can approximate 1 divided by 2 in k degree is to move it in a certain number of bits. So we do this using simple approximation, cheap approximation. We can make our arithmetics. So you can see the difference. It's not much. It's 1.4 times. However, next,
посмотреть на, скажем, там внутреннюю реализацию сортировки,
the internal realization of counting sorting. Using an array, we can calculate the number. And if we sort short numbers, they could be negative and our index is positive. Then we move it by 32,000. And then we get an array from 0 to... And we can make it faster. We can make a different mapping using logical, using this mask. So we're going to get positive numbers and this mapping, but it's going to work faster. So the difference is almost 3 times. If we're using bit mask, if we have several logical Boolean
можно это все запихнуть в
values,
целое число и использовать биты. Что такое boolean?
We can use
И с помощью
booleans or bits, and using certain manipulation, applying masks, we can calculate those logical operations. Example, when we can use it, if we have some transport, if there are jets flying on certain days, and we would like to have a timetable on which days the jets are flying. We have 7 days in a week, so we can use 1 byte to store this information, and 1 reserve bit, the 8th bit or 7th by index, we can use to indicate whether it's summer or winter time frame. So to know whether it flies on Saturday or Sunday, we can use this formula, or it could be different formula when you compare those masks. The difference here is not much, only 20% gain. However, sometimes it's more convenient to read the code and to store this into the database, so you can note it. You can determine the degree for 2 is n number degree of 2, so we're moving from right to left, and when we find this 1, we need to understand whether there are 1s further, whether the number is 1 or not. So it's quite simple cycle, more or less clear. I believe that everyone can manage it, but we can determine it without cycles, without if, just by this formula, n minus 1 multiplied by the number n. And we compare this with n, because n is not as a degree of 2. And before making any calculations with bits, most probably there are optimized algorithm tricks. The difference here is quite interesting, 1.5 times faster. As to algorithms, there are a lot of algorithms, such as sorting. So if in a certain code you are using sorting by insertion, you can use pair insertion sort when there is not 1 element but a pair already. Or you can use merging sort or a hybrid to sort almost sorted data. And if you have, if you are sorting real numbers, it's better to use radix sort for big arrays instead of quick sort. Types of data. We all know that in Java there are primitives as well as in other languages, log, int, char, byte. In Java there are wrapper objects, and many do not understand what it means, and they are using them. They are using log, boolean, so it has each primitive has its wrapper. So if you don't know why you need to use a wrapper, you can make a primitive. So, to quote the difference, I've taken 60,000 numbers, applied them to different sorts of data and sorted them. And sorting a list, as we mentioned, works much slower than sorting arrays, because the list is first converted into array, sorted, and then converted back into list. Sorting of objects is much longer than sorting the data, because there is team sort used, there are objects, and there are huge costs.
Потому что используется сортировка подсчетом, и она быстрее, чем quicksort, но на определенных размерах. Поэтому, если в
So that's why
вашем приложении вы часто используете,
if your
сортируете ваши
application
смотрите на их тип,
uses data sorting quite a lot, take a look at the type, and maybe just through the change in the type of data, you'll be able to improve the performance of your application. Now, parallel computing, talk about Java. There's a very cool package, java.util.concurrent, that has a lot of interesting things. And if you need to parallelize something, you define one method for compute, then write business logic, and the rest is taken up by Java itself. For instance, we have a problem. We have an array, and we have a method processing some range. So if you take a look at a classic solution shown in academic books, what do? If the range is not very large, we don't run any parallel computing, we just process the data and then split our array into parts. And on parallel, we process the left hand and right hand part. So it's a simply looking algorithm, easy to understand. The problem is that in invoke all, mainstream will be waiting until the other two will be completed and will not be doing anything. And that's not optimal. To fix that, we propose a different schematic. So we do class my task extends computer completed. We run in parallel the processing of one part, the right-hand one, and then we process on the right hand in the cycle. And if it's small, we just process it after the cycle. And in this case, the number of threads will be just half of those. The lower the number of threads, the better. So even this parallelism can be written correctly and incorrectly. Same. Now that we've started talking about parallelism, there are lots of classes in Java, different implementations. I need to read the Java doc in order to understand what they're intended for. Don't use multi-threaded versions for a single-threaded application. So you can use it physically, but that will be very inefficient. So, for instance, release is in a array list in single thread implementation, copy and write array list in a multi array implementation. You see the difference in performance is quite considerable. It's just something you pay for synchronization. If you don't have parallelization, then why do you need that? Now, about SQL. Imagine we have a table with a tree-like structure. We have some parents and children, and we need to output information about the top level parents, including the node cells. How do you do that? You specify the node, indicate the ID, and select from node where this ID is ID. Then you do parent and run the cycle. But the essence of working with databases is such that you should try to get all the information in one call. In SQL, you do it in a very simple way. There's recursion, and what we've just said can be written this way. The recursive select that will give us what we want. And that would entail just one request to the database. So and the gain will be quite considerable. Another example from life experience, we were developing a platform. There were different data models there. And from the viewpoint of the bosses, well, they said it's bad, it's not extendable, and you need to implement just one, a universal one. So what's said is done, and how was it supposed to work? We have just one element, and we need to take its children. So In a system, there's a list of providers. We take every provider. We tell it to give you all the children of this element. It issues you a list. We collect it all together and get an answer. Everything seems to be okay, but when the entire functionality was migrated to the platform, it started to work very slowly. So for a last test project, it would take 55 seconds instead of 5 seconds. So what was the reason? Well, they started optimizing it, looking for the problem. What was the essence? They built a platform, the MVP, minimum value product, registered some providers. Everything was flying very fast. The bosses were very happy. But they didn't run load testing. So they should have started 2,000 providers and to take a look at how it was working. And here we arrive at the topic of testing. Firstly, you need to run unit tests for correctness. That's a must-have. You need to run performance testing, benchmarking. So if we have done some implementation compared to a previous one, we need to check if it isn't working slower. You have to do stress tests, smoke tests, and write tests for every bug. You also need to remember about test coverage. Yes, you can say that you have tests, and then it turns out that the coverage is only 10%. You need to keep coverage not lower than at 80%. And also, now that we've talked about Java, you need to take a look at languages. Regarding performance, firstly, choose the applicable data structures and algorithms. Experiment. Look where it runs better. And if it runs worse, try to understand why. Read books, browse the internet, find algorithmic tricks. And by the way, there's a book with the same title. I need to write tests. Please raise your hands those who don't like writing tests. Okay, who don't write them at all? Who doesn't? We have some hands. Hey guys, please ask your colleagues so that they should write tests for you. They will be happy to help you. Also, I have to remind you that programming is not exactly maths, and you need to take account of that as well. When you're given some problem to solve, to define something with two dots, you need to look as deeply as you can, trying to optimize as much as possible. Thank you for your attention. Over to your questions. Vladimir, thank you for your presentation. Dear friends, please don't forget to leave your feedback for Vladimir. And we are going to have a prize for your feedback. We'll run a drawing. And now we have microphones in the aisles. Please come up to them and ask your questions. We also have gifts for the best question. That will be a book from the Peter Publishing House. And also Vladimir brought some of his own gifts. Yeah, just a minute. If anybody of you has examples from your experience, how you optimize code, please give me, you've seen my email address, so please write me. Hello. Firstly, thank you for your presentation. I use some of your practices myself. What's your name? My name is Dmitry. I'm sorry. So the optimization of the known mathematical formulae in real programs sometimes turns into a guilty pleasure. There's nothing left of the original formulae, and in some cases you can't even understand what's happening. There are no comments, no explanations. There's some approximated formula that you don't have an idea what it's doing. And you've also given an example. Let's simplify, and then you've got nothing left of the original formula. So how much do you encounter this line in your real life? Well, it's very dangerous to do that. And from my experience, I would say that if you have the code that doesn't have test or description added to it, you don't understand what it's doing, write this code from scratch again, and that will be much more useful for you. You'll have the comments, you'll have tests, and most importantly, you'll know how it works. It's much better than trying to understand how someone else's code is running if you don't have full understanding. Well, maybe it's not the right approach. Sometimes you need to find the author, but in certain cases, even the authors have forgotten why they made certain choice. So if you don't understand the codes, do it yourself. Redo it yourself. Well, the bosses may not like it, but what else to do? Do it as a secret from the bosses. Hello, thank you for the presentation. In the presentation, you were talking about the optimization of the medium execution time. Have you had experience fixing some spikes? Like, for instance, when the release is checking a certain array, some single operation will be showing very bad results with the average execution time being quite good. Well, I haven't had situation of that in my experience. It's either working well and everywhere, and if it works slowly, then it's more likely to work slowly everywhere. But if there's a spike for some special case, well, for instance, if we run on a virtual machine and it may have worked slower because of that, but I personally haven't had problems like that in production. Thank you.
Владимир, спасибо большое за доклад.
Vladimir, thank you for your presentation. My name is Georgi. In the presentation, you mentioned a phrase that's quite close to a lot of us. We're programmers, and let's optimize. We're programmers, let's optimize, and again. In your experience, how were you able to stop this process? What was the moment where you understood that it's time to stop? Well, look, firstly, I didn't say that it's not that we're programmers, and there's a certain test how to determine if you're the real programmer or not. If you're interested, come up to me, and there's a test. But we were looking at if either the boss would come to you and ask you, look what you're doing, everything used to work, and what you're doing now. And the second thing was stress testing. There are some empirical rules, so you should exert the load that is 4 times as high as the expected one and see if everything works okay. That, I think, is the basic rule of thumb. I was talking about JDK sorting. Well, I guess I won't be able to optimize it anymore because it's been working for 4 years now. But I mean, everything has changed. Thank you.
Добрый день, спасибо за доклад.
Hello. Thank you for your presentation. My name is Alexander. Georgi asked the question I had intended to ask, but there's still a small part left. You were talking about the criteria for good quality code. It's not enough that it should be formal, it should be working correctly. This indeed is must-have, but it should be readable. It should be clearly written, especially for those people who come after us. So where again is that brink, that line? So, for instance, you join a project, you have optimized code, but you don't understand what's happening with it, especially Java. Java is like a mammoth of object-oriented programming. You were also mentioning primitives. And how does it combine? You being a Javist, and how does it happen that you don't use the standards of the language itself? Maybe I formulated it a little bit wrongly, but I hope you have understood me. Can you reformulate the question? Just a second. How? The object-oriented approach of Java combines with certain practices, optimization practices, where you're going away from this approach. And how often does it happen? Well, I've never seen a connection between object-oriented programming and optimization. So for the most part, object-oriented programming is about writing understandable code and optimization. There are lots of cases where you only have bits and bytes and you don't even understand what's happening. So I don't see, I don't personally see any connection. So it's mostly about writing the code that people can understand. Okay, I got you. Thank you. Any more questions? My name is Jenya. I would like to ask you. You were talking about the testing of Raylist. Wasn't it a better way is to go into the documentation and to see where's the start of the array? Well, I understand it, but O of N in some implementation from one may be worse than O N. So you can use some constant. The size of the array may be different. Well, the results will be different, so it's important to do measurement on production data, the sizes that are expected in real life, and you have some implementation. Instead of this array list, you can substitute a different list, take a look how it works, and most importantly, take a look at the difference with the help of a profiler to see which methods have become hotter and which ones not. So, yes, of course, you need to write the documentation because everything is written there with the classes trade safe or not trade safe. But one can also say that quicksort is a logarithm of n, and insertion sort is logarithm squared. Nevertheless, insertion sort is still used, even though its complexity is quadratic. So these are all synthetics. It's all about mathematics, and you have to look at the real-life data to make the right conclusion. So, dear friends, please don't be shy. Come to the microphone to ask a question. Hello, my name is Marwan. A question. Can you recommend how to motivate colleagues for code refactoring if, from their point of view, the code is readable and you don't like it? How to make them use better? How to motivate them to do that? How to motivate them?
Ну, просто вот там
Well,
чай вместе и говорить, ну,
just, talking to them over a cup of tea and saying you want to become a real programmer. And again, if a person does want to become a better programmer, if they're eager about learning, but if they're not, nothing will help. I usually run a couple of presentations explaining how a good quality code should be written, and basically this presentation is like one of those. And then I see how people are writing, and then if something you come back to them and say, you remember how I explained it should be done, and then they correct themselves. So apart from motivation, you also need to do a bit of teaching, right? And I try to do that. I try to share my experience. Hello, my name is Alisher. Thank you for your presentation. It's very exciting. My question is, I'm basically from the .NET camp, so please don't throw things at me. So basically, whatever you said is applicable. Everything is cool. The only thing that I'll have to take a look at multi-threadedness, because there are some differences. But my question is about something else. You said, well, your slide said that merge sorting is applied to the almost sorted arrays. How can we know if the array is prepared how to select the data? Here, my answer would be quite simple. Just open the source code of Java util.pivotquicksoft in my sorting, and then take a look how it's done in the code. Yes, look at the source code in any JDK there's archive source.jar or zip, and there you will be able to see all the source code. If you have any questions to me, my email is in slide 1. Please write me. So you first check if it's sorted enough, and then we apply the sorting. Yes, of course, naturally. Yeah. Dear friends, we'll be able to take one more question.
Здравствуйте. Спасибо.
Hello. Thank you very much for your presentation. My name is Sergey. I would like to ask
У программистов
the following. Programmers,
получается сделать
when they manage to do their job well, everybody likes that.
рассказать из своего опыта,
Can you share
такой запоминающий,
from your own experience some really memorable
которую вот вы выполнили,
problem that you solved?
не знаю, очень
And I don't know,
оптимизировали или
I mean, optimized something very well, and we're very happy. So it started working a billion times faster. You know, this is the question I always ask my candidates in interviews, hiring interviews. So, answering your question, in the first slide, I mentioned that the printing system was based on BinServ. This piece of code, this functionality, I wrote it once and sold it 3 times. I worked in other companies, and they had platforms. They didn't have printing, a good printing system. And I was taking my code as a foundation and was even improved, which I naturally remembered, had in my mind. I was improving it, and I was able to achieve a very good result. So this is an example. In programming, the rule of thumb is write once and sell 10 times. The last question again, Alisher. You started talking about your best code and what you're asking in hiring interviews. I also like asking the candidates, what's your biggest fuck-up? What can you remember, or what you were not able to implement as you had intended? Well, the time is limited. We'll meet separately because it's quite a long subject. But so I suggest we take one more question. Well, I'll be outside the room. Come to me and we'll discuss that. So, hello, Vladimir. My name is Alexander. Can you explain where's the fine line between the cleanness of the code and optimization, and which of these two is more important? Are there cases where in Sber they optimize the codes at the expense of cleanness? We're talking about my code that I like very much. It's my sorting code. It's when you write code and you don't like it. Like, for instance, you paint a picture and you don't quite like what you manage. Yes, it does work. It works correctly. And then you think through it again. You write it in a more elegant way, and it turns out to work, to run faster. I've noticed that there are times, there are cases where ugly code works slower, and the more elegant code runs faster. But whether it's elegant or ugly, it's only about your personal preference. I also have a brief question. Do you use a neural network in writing code? I don't yet, perhaps yet, I don't know. And again, sometimes you get some ideas, and that's enough. But like I have experience LLM improving my presentation. I like that. Also, I ran an interview, offered a problem. The person started to write code, and this artificial assistant started to offer its solutions, and then I could check. Thank you all for your questions. So please use this QR code to leave feedback. And while we're not done, Vladimir, can you select the best question? The first three persons who asked the question, the last two, if they remember in which order, the first three and the last two. Dear friends, please raise your hand. Please come here, and Vladimir will hand the gifts to you. Vladimir, thank you for your presentation. Thank you very much. That was incredible. Dear friends, let's say goodbye to Vladimir.